Got problem number 51. All right, for number 51, we have a 75-meter high bridge, which is way up there, and the log passes under the bridge, moving at a constant speed of 5 meters per second. What's the horizontal distance between the log and the bridge if when the stone is released, it falls down and hits the log? All right, so what we got is blue for water. All right, here's the swiftly moving water. And in the swiftly moving water, we have a log. It's going this way with a velocity of 5 meters per second. All right, so v of the log is equal to 5 meters per second, and that's constant. Okay, acceleration here is equal to 0. So this is going to go a certain distance. All right, and as it turns out, we're up here on the bridge, 75 meters high. Delta y is 75 meters, and we're going to drop a rock, and we're going to time it so that the rock comes down and hits the log right here. Move the log here. All right, so now it's going to hit the log when the log is directly underneath it. Okay, so here's the deal. We know that the log moves a distance delta x horizontally as the stone falls a distance delta y vertically. Okay? So if we know how long it takes to fall 75 meters, which we can figure out, we can figure out how far back it must have been from the place it hit if it's moving at 5 meters per second, so that at 5 meters per second in this amount of time, it gets right to here. All right? So let's see. The first thing we need to do is figure out how long it takes to drop 75 meters. Okay? Because the time is constrained by how long it takes the rock to fall. All right, so speaking in the vertical, delta y is equal to 75 meters. We'll take downward to be positive again. We can do that because both g is positive. Everything is pointing downward, so we'll just call that positive. Delta y is 75 meters. Acceleration is equal to g. We don't know time. That's what we want to know. And we know v naught is equal to 0. That's our gift. So we say drop or released from rest. All right, so now we know that t is equal to what? How are we going to figure this out? We have all the things we need to use the meat grinder equation. So we're going to say delta y is equal to v naught t plus 1/2 gt squared. Again, all right, emphasizing that we're taking downward to be positive. All right, and since v naught is equal to 0, we have a gift here. And we'll find that t, same expression as before, is equal to 2 delta y over g. All right, remember I said that's why we solve things algebraically. This should be familiar. Now that we've got that, we say, oh yeah, I've done this before. All right, so now we need to know how far the log will move in this amount of time at a speed of 5 meters per second. So that's how far away the log must have been back this way, again, right, when the stone was dropped. So now we'll move down and we'll do the log part in blue. We know that the distance that the log moves, delta x is in the horizontal, is equal to v naught times t plus 1/2 a t squared. But the acceleration of the log is 0. It's moving at a 5 meter per second constant velocity. So we know the distance that the log has to be is equal to delta x is equal to v naught. That's our v naught, v initial, v constant. 5 meters per second, right, times the square root of 2 delta y over g. All right, we're just going to bring that whole expression down here, so we're going to have to do one single calculation. We can save ourselves some error. 2 times 75 meters divided by g, 9.8 meters per second squared. And of course, we're taking the square root. Meters divided by meters, 1 over second squared. Square root will be seconds. Seconds times meters per second will give us meters here. Meters for delta x. That's perfect. So we're doing a little estimating to see, to keep those skills sharp. What kind of answer should we expect? Well, we've got 2 times 75 is 150, divided by approximately 10 is about 15, so it's a little bit less than 4 seconds, so a little bit less than 4 seconds times 5 should give us approximately 20 meters. So let's see, we'll get delta x and plug it into the calculator, and we get 19.6 meters, which, as we said, is a little bit less than 20 meters. All right, so the log has to start 20 meters away so that in the amount of time that it takes for the rock to fall, 75 meters, approximately 4 seconds, it will have moved 19.6 meters so that it's directly under the rock as it falls.